Calculus in building a suspension bridge. So our STEAM project was about building a suspension bridge and how does it work. So we chose this topic this year because it got our attention due to the fact that we're taking AP Calculus and it's somehow related to the mechanism which it works. So the suspension bridge is a type of bridge which the deck is hung below the suspenders as you can see over here. And then they are suspended between those towers, those two green towers as you can see here. So all the pressure is being converted from this horizontal deck, which the cars are flowing over and driving above. So as the traffic crosses, we were confused. How does it still stable while we have this gap that doesn't have anything to hold it below it in the middle? This is the calculus we're trying to reach in the suspension bridges. So it also includes a lot of physics and, as I mentioned before, calculus, and it's a magnificent piece of art that we are interested in studying. So, every research starts with problems that we and questions we don't have answers to. So we first stated that how does a suspension bridge stay up when the towers are so far apart? How is it still stable when we have two different poles over here and then there's nothing holding it from down? And what causes the bridge to stay up when the base when the base in the middle of the bridge? So we don't have anything under it in the middle. How is it still stable and not falling apart? So we wanted to know what the mechanism that keeps the bridge stable and how is it related to calculus? How is calculus going to help us understand this topic? So the hypothesis we gave is that the cables hold the bridge by attaching the towers. So those cables are attaching right through the different poles we have down to the middle, which results in the bridge to be horizontally stable and not fall apart in the middle. Of course, we faced a lot of obstacles studying this topic, but due to the fact that we did a lot of research and the AP calculus we're studying also helped a lot, it gave us a better understanding of this topic and helped us to find the guide to how to understand the suspension bridges.
Research. So we learned from the research of the suspension bridges. We learned that it's one of the most prevalent types of bridges created around the world, and they are created by long horizontal decks are suspended below the suspension of the bridge, and the wire suspended from vertical rods or hangers, assuming that the risk is negligible when compared to the deck and the vehicle's weight, are completely supported. And the suspension bridge's primary cable are shaped just like a parabola. And as we research, Morris Klein's studies has helped us a lot, especially the Morin Klein's calculus and intuitive and physical approach. When the total weight of the load and the cable and the highway per horizontal foot is constant, calculus allows us to determine the geometry of the bridge cable, and the cable is supposed to be inelastic and fully flexible, and it bends without resistance, which means it does not stretch or contract. Luckily, a regular piece of rope provides both characteristics. And the question from the learning story that's related to the research of the suspension bridges is what have you learned? So from the learning story, they ask what have you learned, and we learned that the STEAM project of a suspension bridge has helped us understand the different real life use of concepts in physics and calculus in building bridges and the importance of them.
Calculus formulas in suspension bridges. So basically, these are the formulas that were used in creating and sketching the suspension bridge in general. Uh, we also use these equations to calculate the height, width, and base of the suspension bridge. As you can see here, we have the suspension bridge graph. We have the cables that are hanging off the poles. We have these hangers and also the roadway where the cars are on. Here we have some formulas and B locations. As well, here we have the calculations of the formulas that were used before, as you can see here. And also for the learning story, the, the second question, what obstacles have you faced? So basically, In building the model, we faced difficulties in finding the suitable cable that enables the bridge to serve its purpose and work in a good way, while being balanced with the other materials used. Difficulties also include finding the correct calculations to build the bridge.
And these are the calculations we used to make our model. First of all, here we have the equation of parabola that we used with the string. This is the string that makes a parabola shape in the suspension bridge. We took the dimensions of the distance between the two poles, the distance of the poles itself, and then we put them into the equation of the parabola, and this is what we got. And here we calculated the tension of the strings on the suspension bridge within the using physics. We use lambda, length, mass, gravitational force, cosine, sine, theta, and all of that. And then here we have Newton's second law, in which we used F net equal m times a. We put in all the dimensions and we used equations, distance, we used distance, gravitational force, and all of that. And here we used the Pythagorean theorem to find out everything related to the dimensions of the bridge and the strings and the poles and all of that as well.
And now we are going to talk about the sketch and materials of our project. This is how the sketch is looking like, and the materials used is they are popsicle sticks, wooden deck, chopsticks, wooden dowels, and LED lights. And overall, this is how our model is looking like at the last stage. We just worked hard on it. And now what could be added to improve our project? The project could be improved with more expensive materials and a bigger platform for it to endure in the model.
Now to the scientific report part of the project. We answered the full report about the project. So first of all, to define our main problem was that how does a suspension bridge stay up when the towers are so far apart? So how does it keep stable and keep balanced? Next, we had to research and gather information that suspension bridges have different components that help it stay stable even with a lengthy distance between these two towers. And then we hypothesized that if we can connect smaller cables to the main supporting cables of the two towers, this will help balance the bridge and the base. Next, in conclusion, we found that to make the bridge stable, we should connect small suspender cables to the main cables that are connected to the two tall towers at the sides of the bridge to hold up the base and take off the pressure and the tension from the base of the bridge to the supporting cables and the two towers. Here are the math concepts that we used, and this is also an answer to one of the learning story questions, which is what are the math concepts that we used in this project. We used concepts such as Pythagorean theorem, symmetry of parabolas, vertex form of quadratic equation, differentiation and integration to help solve the problems that we were facing throughout the project. Other concepts we used were such as architectural design and knowledge in civil engineering. And at the end, the obstacles we faced are that in finding the compatible materials, we had a hard time because we wanted to balance the bridge with the required calculations. We also found that the bridge is stable when we connect the cables and allow the tension and pressure to be on them and the two supporting towers. In the end, as a conclusion of this project, as a group project, we divided everything among everyone in the group, so everyone had his own job, which made it easier on us and much quicker to finish. And as well, with hard work and working on one hand on the same ideas, we ended up making this project. And however problems we faced and obstacles came into our way, we found a solution to it. And throughout these many stages, we reached the final stage that all of us are proud to reach with the full research, with this PowerPoint and the model that we created. And thank you very much.